This video will present the second step of the four-step programming process as we continue to develop our quadratic equation program. Let's go ahead and take a look at the code again. This is what we developed when we had quadratic step 1 of 4. Our first pass through, we had our main steps. We initialize the program, we get the coefficients from the user, we calculate or process the quadratic roots, we display those roots to the user, and then we end the program. Now, each of these is critically important. You can't do this program if you don't get the coefficients. You cannot run the program if you, or at least successfully, if you don't calculate or process those roots. And it doesn't help to do any of that stuff if you don't show them to the user when he's done. So what we're looking at here is the complete program, and that's the good news. However, what we need to do is expand on this. What does it mean to get the coefficients? What does it mean to process the quadratic roots? Or even to initialize the program. So we're going to continue with that now in an iterative refinement kind of way. So we'll go ahead and save this now as step 2. We always have to keep track of that so we don't overwrite our steps. We always want to have our step 1, 2, 3, and 4 as we're finishing through this. You always want to be able to go back and look at the previous parts of your design as you went along. So, as I mentioned, this is called iterative refinement. We start with a step here, and we did another step, and we did another step, and we went all the way through. Now we're going to do it again, iteratively, meaning repeatedly. We're going to start back at this top, and we're going to refine it. We're going to make it just a little bit better, a little bit stronger. So, for example, in initializing the program, we have a couple of items. One of them is we will be initializing the variables if we need any. And one point about this is that variables in a structured programming environment are always initialized at the beginning of the main function and all of the other functions that you'll be using. Initializing variables or creating variables anywhere else in the code is actually legal in some languages, including C++, but it is terrible engineering. It's terrible software development because you'll have people having, when they're trying to read your code, they can't find where a particular variable was initialized or if it was initialized at all. And so that makes it difficult. So we'll initialize our variables, and the other thing for this program is we'll go ahead and show a title. And most programs will have some kind of title, and so we'll go ahead and show a title for this. So now, one of the things I want to point out is that I had a problem here. When I first developed this program, I stated that the program had to be initialized. A very abstract-y kind of thing, because I didn't really specify what that meant, but I knew the program had to be initialized. So now, as I come into this particular item right here, and one of the points about this is my entire world right here. I'm not thinking about coefficients or calculations or presentation. I am only thinking about this one small part because your brain only has so many working memory cells. If you try to put it all in your brain at once or keep track of everything, it'll never work when you get to your non-trivial programs. So I said, what does it take to initialize the program? And this is my iterative refinement here. I said, okay. It's going to take initializing the variables, and then another initialized program or start up the program component is showing the title. So now my next step is I've generalized or abstracted what I call getting the coefficients from the user. So I'm going to say, well, what does that mean? Well, in the quadratic equation, I need 3 coefficients. So I'm going to say get coefficient A. I'm going to say get coefficient B, and I'm going to say get coefficient C. Now, these are the coefficients that are required in the calculation for the quadratic equation. Again, when I first wrote this program at the step 1 level, I just said get the coefficients from the user. I knew I needed to do that. Now I have refined it. I've said, okay, look, here is exactly what that means, getting coefficient A, B, and C. And again, I'm only concerning myself with this one little part. I'm only solving a small problem here. One of the main parts about things that you will learn from programming is never try to solve big problems. Always tear them down to smaller problems, and you could get them solved much, much easier and much lower anxiety level. Next, I need to process the quadratic roots. And again, I know that there's some calculations to be done here, but I didn't specify them initially because I was doing this at a high level or abstracted level. And so what I'm going to do now is I'm going to break the problem down into smaller pieces. For example, the part under the radical decides whether these are going to be real or unreal roots. So I'm going to calculate the discriminant first and make sure I get that number there. Then I'm going to calculate the square root of that. And once I have that, I can go ahead and calculate the denominator. We know that's not very complicated. It's just 2 times a, but it's nevertheless a module. It's a component of this calculation here. Now with the discriminant calculated, and then its square root calculated, and then with the denominator calculated, I can now go ahead and calculate the roots. So I can move ahead here and say calculate roots, but I'm abstracting a little bit now because I know there's 2 roots. But I do have all the components necessary for doing those calculations. I'm ready to do that. But I want to note here that I can even break this down a little farther, and I can calculate root 1, and I can calculate, let's bring that where we can see it, root 2. And this gives you the opportunity to see how you can continue to expand and continue breaking down the problem into bite-sized quantities. This is a further extension of the iterative refinement process that we're doing. So we broke it into the major steps here of step 1 into all these major, and then initialize program, get coefficients, process the quadratics. And now here we're breaking that down into these items. We get down to calculate roots, we can break that down even further into the calculate of root 1 and the calculate of root 2. So finally, when we come down to displaying the roots, again, I focus only on solving this one little problem. I'm not concerned about the rest of it. I trust that one at a time, I've taken care of solving each of these problems. So when I get to displaying the roots, I only solve one little problem, and that will be to display root 1, and then I can display root 2, and now I have solved the problem identified on that line. And again, I've driven that iterative refinement to make that occur. So coming back through, I don't have anything more to end the program with. I'm already returning the success. If we notice that we started with our step 1, and you know where step 1 is, because they're the outer comments here, and there's only about 5 of them. And remember, we don't want any more than 8 or 10 in any particular level. There's only 5 in the main level. There's 2 here, 3 here. There are 4 here under this one, and then 2 under that one, and then 2 under that one. So you can see you'll never really need to go. 8 to 10 is actually pretty high. But there are times, for example, in display parts where you have to just display a lot of things or put out a lot of actions to make the display work. You might have more steps. But very commonly, 4 or 5 steps is very common in a given level. And so you can see how to break that down. Anytime it starts getting too complicated, that's telling you that you need to break it down into smaller pieces. So we'll go ahead and save this one. We're quad S2 of 4. We'll go ahead and compile it. We really haven't added any code, but we're going to compile it and make sure everything's good, and it is. So we have that wrapped up, and we can come back here and we can finish up this video. Again, what we've accomplished in this step is we've taken step 1, and one small piece at a time we've iteratively refined it so that now we know what every single step of the program needs to do. And that's key, because when you're writing code, you don't want to be trying to solve the problem at the same time. That's virtually impossible when you get into non-trivial programs. This is a pretty lightweight program here, and you might be able to hack your way through it. But that's not what we're teaching you toward. We're teaching you toward the real circumstance of having very complicated, what we call non-trivial programs. And so you really need to break them down into smaller pieces and then keep breaking them down until you've gotten down to the pieces that you can actually solve with code pretty much a line at a time. So that will end this video, and we'll be prepared to go on to the next one very soon.